Hello friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
Hello friends, today we'll show flow simulation through SolidWorks. Here in this case we will provide a special type of pipe. What I will be showing through one end and it will be moving out to two different ends. We'll analyze this one through SolidWorks. Okay, let's get started then. First we'll draw this model using front plane, normal to sketch. First of all, we have to make the center line. Let's make a rectangle at the beginning. Then we can cut some unwanted portion. Let's provide a smart dimension to this one. This one is 100 mm only. Down also it will be same exactly. And this one you can make also 700 mm. Done. And with respect to the central line, we want to make these two symmetric, so we have to apply some kind of relations, right? Selected the three lines, and then with respect to central line, this one will be symmetric. Relation applied. Okay. Now next one we can put some kind of fillet at these ends. Let's provide fillet radius equal to 30 mm. You can provide 30 mm is okay. $40 mm, let's see. Yeah, 40 is also okay. 40 mm we have provided, right? Fine. Drawing is complete. So what should we have to do is green check and exit from the sketch. Next one, select the sketch and features, swift boss base, and we want to provide a circular area. Let's the diameter be 25 mm. Done. Now we want to do another thing. That is, these two are the exit of fluid, and we want to make one entry. So this part we have to make another pipe, right? Let's select the right plane, normal to. Change the plane again, right plane. Here at this place we have to draw another pipe, right? So we'll sketch center line, and another center line is required to get the center point of the circle. Let's draw the circle. Smart dimension to this one. Let's provide 25 mm. That means the entry pipe and the exit pipe both are having same diameter. Okay, drawing is complete. So exit from the sketch. Select the sketch and features, extrude boss base. You have to extrude in the opposite direction, so change the direction and let the extrude length maybe, let's make this one as 150 millimeter. Done. Drawing is complete. Now we have to make some hole inside this, so we should depend on shell. Select the faces. This one shell thickness equal to 2 millimeter only. Done. Now we have to check the drawing is okay or not. So for checking this one, we can make a segmented view. We can cut this one from front plane and let's see whether the joint is okay or not. Yeah, so it is perfect, no problem at the joint itself, right? The drawing is perfect, clean. Now to go inside this environment of flow simulation, first of all we have to see while fluid will be passing through this one, it should be completely transparent, right? We have to make this object transparent. So select that object, transparency is changed, but we have to change it transparency from the inside also. It is only from outside it is done. We select the object again, transparency is changed, so object is completely transparent, right? Okay. Now another thing, very important thing is, while going for fluid flow simulation, one closed volume should be generated. That means inside this closed object we should consider fluid flow, right? So for doing this one, we have to make some caps at this entry and the exit points. That can be done from the flow simulation itself. One tool is available, create lids. For creating lids, only the surfaces to be selected. It will be done automatically. Okay, let's select the surfaces. One lid is made already, second lid is also made. Now the third lid is required, right? All the lids are ready. Okay, done. Next one, before going for operation, we have to start by saving this work. Save this work by the name of CFD analysis. Okay, save it. We are saving this one in the desktop. We have to see whether the geometry is okay or not. We can check it from check geometry, and we are going for internal analysis, right? First of all, check whether the geometry is okay or not. It is success, so it is geometry is okay. Next part, we have to see whether fluid flow is generated inside or not. It is an internal analysis. We check volume. Fluid volume is generated or not. It is showing perfect, so we can go for the analysis. Okay, close it. We start from wizard. Name of the project is project 1, let it be. Now we're starting next. Unit we are selecting as SI unit. Then next, it is an internal analysis, so we should check on internal analysis. And next, we have to select liquid as water. Our liquid is water, so we select water. Next, we are not knowing about the roughness and default wall thermal conditions, so we'll move to next, and next, finally finish. This is actually computational domain. It is already made. Now while initiating this analysis, you have to hide this computational domain. Next we have to apply boundary conditions. Boundary conditions, insert boundary conditions. It will be inlet mass flow at the entry level, right? You want to provide mass flow rate equal to 0.301 kg per second at this level, right? Now we can do one thing. For applying boundary conditions, you have to click, select other. Okay, done. Another boundary conditions that you apply, that is atmospheric pressure at the exit point. Again, inside boundary conditions, it will be pressure, atmospheric pressure at the exit level. So we select the exit levels, select other. Okay, this atmospheric pressure. To again apply boundary conditions. So it will be atmospheric pressure at the exit point. Select that level again, select other. It is applied atmospheric pressure at the end. Okay, so all the boundary conditions are applied. Okay, now next we have to select some goals. Lot of goals are there, like global goals, then point goals, surface goals, etc., volume goals. We select first global goals. We want to see the velocity flow rate, average velocity flow rate. Okay, click this one. Okay, and so we want to see another thing, is surface goal. So select surface goals. At the surface we want to see again average velocity. Select the surface, select other. Rate 3. Okay, next one we have to run this one. Let's run this. While running this simulation, is very important to see the solver window is very important, because from the solver window itself we can find out what is actually going on inside. We can see velocity, flow, pressure gradient, temperature gradient, etc. at different times. So iterations have already been started. It has gone up to 16 iterations. While completing this one, we can check the solver windows, right? Okay, we'll see the velocity first, right? See, at the beginning velocity is very high. While moving through the exit point, it is normalized, it is reduced a little bit, right? So again, you can check other things, like you can see curves also. You can check volume flow rate. Solver has finished, so we can go for the results right now. Okay, fine, close it. You see the results. I'll see the result first. Very important part is to see the cut plots, right? Cut plots means along a specific plane it will show velocity, pressure, etc., whatever we like to see, right? We'll see the cut plots. Better to see this one in the segmented portion. Make it half of this object by cutting it from 10. Now insert cut plots. We want to see velocity flow along this plane. Okay, velocity, let's see. We have already seen through this solver window the velocity profile. While going through this entry point, it is very high, and exit level it is normalized little bit, it is reducing, right? We can have the values, these pressure values also, temperature, etc. Let's see pressure. Pressure is actually normal level. It is near to atmosphere pressure. It is not changing at all. Let's see temperature. Temperature is also no change at all. Now I'll do one thing. We can have an animation of this one, right? So we clear and hide this one, and we'll go for animation. Cut plot 1, clear and hide, and we'll go for animation. Play it. This is for temperature 1. We'll want to see for velocity. This is the cut plot along the front plane actually. Okay. Next one, we want to see another thing like flow trajectories. This is very important one. Now first, next one, this clear and hide. Next one, we want to see flow trajectories. Insert flow trajectory. We want to see velocity again, and we want to the pattern we want to see in the form of arrows only. Right, let's increase the density of this one, and want to see the surface, right? And which surface? Let's select the surface. Okay, done. Now see the pattern we can see very clearly. If you want to see this one in the form of an animation, that will be better. That will provide a better idea. So what we'll do is we'll clear and hide this pattern, clear and hide, and play this animation. You can have a smooth flow. It is completely symmetric in both sides. So you can see at the entry level, velocity is very high, and at junction it is divided and it is distributed equally, symmetric way. And another thing we can see that while going out, some kind of here at this point, some kind of cavity is created, some kind of like disturbance is there, some gap we can see. Here also you can see some. No, this is because of this plane only. We want to see this in front plane. Let's see in the front plane, then it will be getting better results, right? In front plane. Okay, yeah. Okay, you can see the boundary level velocity is not zero at all, right? This is one very important phenomenon. You can see at the boundary level velocity is not zero at all, but at the exit level at this side we cannot see any kind of velocity, right? Flow is occurring actually towards inside only, inside the pipe, not outside one, right? Okay, let's see another thing like pressure and other things also. Definitely it will be same, but we can see the flow. Okay, right. Now close it, clear and hide. Next one, very important thing, you can see particle studies. That means here in this case what we'll do is we'll inject like massless very small particles of water, and we'll see how it will be moving throughout this entry point to exit point. Okay, so particle studies we are making. It will be started from wizard. Next, we want to inject water from the entry point. I want to select the surface from here. Okay, done. Next one, we have to run this. To run this particular study. Now finally we have to view this by play. Okay, you can see very fine massless particles of water is moving from entry point to exit point, and you can see at the exit point the same thing what we saw in the velocity also. So design is not perfect at all. The design could be made perfect if we could make some kind of like a fillet over there, right? Here it actually is some kind of obstruction is in the middle. That's why you can see some fluids are bouncing back here itself. At the middle position, some fluids are bouncing, some fluid particles are undergoing some perfectly elastic collisions, right? This is about pressure. We'll see velocity. Let's see. So we can see here velocity is almost same. At the beginning, at the entry level, it's little higher. It is in the range of 0.09 meter per second, but at the exit level it is decreasing. It is in the level of 5.01 10 to minus 3 meter per second, right? Finally, we can generate a report that will be in the MS Word format, and in that report we can export all these sketches, all this. We can generate a report from here itself, and all these graphs and all these drawings, even these videos also can be imported there itself. Okay, so this is all about our flow simulation through a special type of pipe while water was entering from one end and it was going out from two exit points, right? If you like this video, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.